Our Shiny is a web application framework for our programming language that provides an interactive and simple way for data analysis and visualization. The official documentation for Shiny can be found at restudio.com and provides comprehensive information on using Shiny for web application development. At this moment, I just introduced Shiny using KWCS data. Prior to start about Shiny, I will review the TAF code. That code will download the KWCS data 6th rows file from the GitHub repository and save it as data/KWCS6THRDS on your local machine. Then, it will use the readRDS function to load the data into R as an object named dat1. This code uses the %% operator from the dplyr package to filter the columns of the dat1 data frame. The select function is used to specify the columns to keep in the filtered data frame. The selected columns are Sleep GP, Sleep Status Group, WWWA1 GP, Weekly Working Hours Group, Short Return, whether the respondent has a short return time from work or not, Shift Work, whether the respondent works shifts or not, NJob, number of jobs, Sex GP, Sex Group, EDU GP, Education Level Group, EMP GP, Employment Group, AGE, Age, Satisfaction, Work Satisfaction. After the data frame has been filtered, only the specified columns will remain in the data frame, and all other columns will be dropped. This can be useful for simplifying your dataset and focusing your analysis on specific variables. Code is specifying that the variables should be stratified by the single variable sleep GP, and that the categorical variables are WWA1 GP, Short Return, Shift Work, NJob, Sex GP, EDU GP, and EMP GP, while the continuous variables are AGE and Satisfaction. The function TAF is likely a custom function that generates the table 1 summary based on these inputs. Finally, the HTML table function is being used to output the results in an HTML table format, which can be easily viewed in a web browser or other software that can render HTML tables. This code defines the UI and server components of a Shiny app, and then runs the app using the Shiny app function. In the UI component, you define the user interface of the app using your code. This typically includes elements like input control sliders, text boxes, drop-down menus, and output displays plots, tables, text. In the server component, you define the server-side logic of the app. This code processes user inputs, performs calculations, and generates output for the UI to display. In the server function, you typically define reactive expressions and use Shiny's reactive programming features to create dynamic behavior in the app. You can separate the UI, server, and global code into separate files in a Shiny app. This can make your code easier to organize and maintain, especially for larger apps. Here's an example of how you can structure your code into separate files. UIR, this file contains the code for the user interface of the app. ServerR, this file contains the server-side logic and output generation of the app. GlobalR, this file contains any global code that needs to be shared across the app, such as data loading or library imports. Finally, run the app. Communication between UI, server. The user interface section of a Shiny app receives user input variables and sends them to the server section for processing. The server section accepts the input variables from the user interface, applies the necessary processing and rendering steps, generates output variables, and sends them back to the user interface. Finally, the user interface receives the output variables from the server section and displays them to the user. User input. The user interacts with input widgets defined in the user interface section of the app. These input widgets can take a variety of forms, such as text boxes, sliders, and buttons. Input variables. When the user interacts with an input widget, an input variable is generated. This variable contains the data entered by the user, such as the text typed into a text box or the value selected from a drop-down menu. Sending inputs to the server. The user interface section sends the input variables to the server section of the app. This happens automatically and in real time, using reactive programming techniques. Processing input variables. The server section receives the input variables from the user interface and processes them as needed. This might involve performing calculations, filtering data, or running complex algorithms. Rendering output. Once the input variables have been processed, the server section generates output variables. These variables contain the data that will be displayed to the user, such as a plot, a table, or a text string. The server section also applies any necessary formatting or styling to the output variables. Sending outputs to the user interface. The server section sends the output variables back to the user interface section of the app. Again, this happens automatically and in real time, using reactive programming techniques. Displaying outputs to the user interface section receives the output variables from the server section and displays them to the user. This might involve rendering the output as a plot, table, or text string, depending on the specific output format of the app. The output elements in the user interface are reactive, meaning they update in real time as the input variables are changed by the user. Now, we discuss an overview of the structure of the user interface (UI) section in Shiny, specifically focusing on the use of sidebar panel, main panel, tabset panel, input widgets, and action button. Sidebar layout creates a two-panel layout with a sidebar on the left and a main panel on the right. Sidebar panel defines the content for the sidebar panel, which typically contains input widgets such as sliders, drop-down menus, or text input boxes. Main panel defines the content for the main panel, which typically contains output elements such as tables, plots, or text output. Tabset panel organizes the UI into multiple tabs, with different content displayed in each tab. Action button creates a button widget that the user can click to trigger an action in the app. Input and output. The first code chunk defines the user interface (UI) for a Shiny app. The UI consists of a text input box labeled "What is your outcome?" with a default value of sleep problem and a verbatim text output labeled "My output." The second code chunk defines the server-side logic for the Shiny app. Specifically, it creates a reactive expression that renders the text entered in the input box as the output. The third code chunk loads a data file named KWCS 6th roads as a data frame called dat1 using the readRDS function from the tidyverse package. This code creates a drop-down menu for selecting the strata variable and a table output object named TableOutput1. The server function subsets the data to the selected strata variable using the input strata variable and creates a table of the frequency of each category in the selected variable. The addMargins function is used to add a row and column to the table with the totals. If the selected variable is numeric, the table function may not be the most suitable way to summarize the data. Instead, you can use the summarize function from the tidyverse package to calculate the mean and standard deviation of the selected variable. This code shows a basic example of a Shiny app, and you can build on this foundation to create more complex apps with additional features. For example, you could add more input widgets to allow the user to select different subsets of data or change the analysis parameters, or you could add more output elements to display different types of visualizations or summary statistics. Thank you listening. Let's start make it.